Directive Number 1. Training Modules for Interstellar Exploration. Module 3. Astrobiology, Planetary Surveying, and Alien Ecosystems. Module 3 trains personnel to study, assess, and safely interact with extraterrestrial environments, focusing on astrobiology, planetary surveying, and understanding alien ecosystems. It equips explorers with the skills to identify life forms, analyze planetary conditions, and uphold the protocols necessary to avoid contamination or harm to both humanity and alien species. Objectives of Module 3. 1. Understanding astrobiology. Learn the principles of life in extreme conditions and the potential forms life might take in alien environments. Study biosignatures and biochemical markers to identify living organisms on other planets. 2. Planetary surveying techniques. Gain expertise in evaluating a planet's atmosphere, geology, hydrology, and potential habitability. Use advanced tools for surface mapping, mineral analysis, and environmental sampling. 3. Alien ecosystem interaction. Understand ecological balance and interdependence in alien habitats. Train in non-intrusive observation and data collection methods to minimize impact. 4. Preventing cross-contamination. Adhere to strict quarantine and decontamination procedures to prevent contamination between Earth and extraterrestrial ecosystems. Module structure. This module is divided into 3 sections, each focusing on a specific aspect of planetary and ecological exploration. Section 1. Astrobiology and Exobiochemistry. This section introduces the biological and chemical principles of life as it may exist in extraterrestrial environments. Key topics. Conditions for life. Study extreme environments on Earth, e.g., hydrothermal vents, polar ice caps, acidic lakes as analogs for alien worlds. Learn about potential energy sources for alien life, such as chemosynthesis and exotic radiation absorption. Biochemical diversity. Understand potential life forms based on silicon, ammonia, or methane-based chemistries, as opposed to carbon-based life. Analyze alien metabolic processes and their implications for cohabitation. Biosignatures and life detection. Use instruments to detect chemical markers, such as methane plumes, amino acids, or microbial fossils. Train in molecular analysis techniques for examining organic and inorganic compounds. Section 2. Planetary surveying. This section equips trainees with the skills to assess a planet's suitability for human exploration or colonization. Key topics. Atmospheric analysis. Measure atmospheric composition, pressure, and temperature. Detect potential toxins or breathable conditions using spectroscopic instruments. Geological mapping. Survey planetary surfaces for structural stability, mineral resources, and potential hazards. Learn to identify seismic activity, volcanic zones, and plate tectonics. Hydrology and resources. Detect water sources using radar and magnetic imaging. Analyze liquid samples to determine potability and detect microbial life. Habitability assessments. Conduct assessments to determine whether a planet meets conditions for temporary or permanent human habitation. Map zones of interest for further exploration or colonization. Section 3. Alien ecosystems and ethical considerations. This section trains explorers to observe, analyze, and interact with alien ecosystems responsibly and ethically. Key topics. Ecosystem dynamics. Understand the interdependence of alien organisms and the roles they play in their environments. Study predator-prey relationships, resource cycles, and adaptation mechanisms in alien species. Behavioral observation. Learn techniques for observing alien species without disturbing their natural behaviors. Use remote sensing tools and drones for data collection in sensitive areas. Non-interference protocols. Adhere to Directive Number 3. Observe, but do not interact. Avoid actions that could disrupt alien ecosystems or reveal human presence prematurely. Decontamination procedures. Train in rigorous sterilization techniques for equipment, clothing, and samples. Understand quarantine procedures for personnel returning from potentially hazardous environments. Cultural and ethical sensitivity. Study scenarios involving intelligent life and learn protocols to communicate humanity's peaceful intentions. Uphold ethical standards to respect alien life and avoid exploitation. Training methodologies. To ensure thorough preparation, Module 3 utilizes diverse learning and training methods. 1. Simulated environments. Trainees practice in controlled ecosystems replicating extreme planetary conditions. Hands-on sampling and analysis of simulated alien biomes. 2. Fieldwork on Earth analogs. Explore extreme terrestrial environments, such as deserts, glaciers, and deep-sea vents, to apply learned techniques. Conduct real-time atmospheric, geological, and biological assessments. 3. Virtual reality scenarios. Train in VR simulations of alien worlds, encountering diverse challenges like harsh weather, reactive chemicals, or alien species. 4. Laboratory work. Practice analyzing atmospheric samples, water chemistry, and soil composition. Learn to identify biosignatures and microbial life under microscopic and spectroscopic analysis. 5. Ethics workshops. Participate in discussions and case studies about ethical dilemmas in alien contact scenarios. Role-play potential first contact situations to explore decision-making in morally complex situations. Evaluation and certification. Trainees must demonstrate mastery through rigorous testing and hands-on assessments. Perform accurate planetary and biological analyses in simulated and real-world environments. Successfully identify biosignatures and assess planetary habitability. Pass ethical and procedural tests on handling alien ecosystems and preventing contamination. Certification as an exobiological survey specialist qualifies trainees to lead scientific missions focused on planetary exploration and ecological research. Conclusion. Module 3, Astrobiology, Planetary Surveying, and Alien Ecosystems prepares humanity's explorers to approach alien worlds with scientific curiosity, responsibility, and respect. By mastering the techniques and ethical guidelines outlined in this module, trainees ensure that interstellar exploration remains a constructive and peaceful endeavor. Dr. Ong Der EDF